So our last three ways that we can be asked to find the slope are we can be given a graph and asked to find the slope, we can be given an equation and asked for the slope, or we can be given a scenario and ask ourselves, okay, what is the rate of change? What is the slope of this scenario? So let's start off with our graph. When you're given a graph of a straight line, that means that you have a constant rate of change. So when I have a constant rate of change, I can find that number. And here are my steps to find that number. So my first thing when I'm given a graph and asked to find the slope is that I need to identify if the line is positive or negative. So remember, the way we do that is when the line, so we're given our line and we can write our name on it. So I can write Miss Bultman. If my name goes upwards, that means I am working with a positive slope. If I write my name and it goes downwards, then I'm working with a negative slope. So my first step is I'm going to look right here and I'm going to say, okay, is this positive or negative? When I write my name on it, it goes downward, so I know that this slope is negative. So I'm just going to make note of that, and I'm going to say that this slope is negative. Then we're going to choose 2 points that are directly on the grid line. The important part about this is that when I'm picking my 2 points on my line, it doesn't matter which 2 points I pick as long as they fall at one of our grid intersections. So you know how we have these little squares, it's going to fall on one of the corners of those squares. So when I'm going to find my 2 points, I want 2 points that are on the grid. I know exactly where this point is located. It's located at -1, 3. So then I need another point that I know exactly where it's located. I could choose this point. I could choose this point. So we want one that's exactly at one of the corners. Step number 3 is to follow the grid to make a right triangle. So this is exactly what we did when we were finding the distance between 2 coordinates. You're making a right triangle by drawing a horizontal line and a vertical line that stays on the grid line. So what I'm going to do is I'm going to draw a vertical line coming from this point, and then that needs to connect to this other point with a horizontal line, and that creates a right triangle. Then I'm going to count the vertical height. We want to pay attention here to make sure that each box, that we know how much each square is worth, because that has to be included when you're finding the vertical height. So in this case, we're just counting by ones, so that makes it easy. 1, 2, 3, 4, 5, 6. So my vertical height in this case is 6. I do not know why I wrote 4 when I just said 6 out loud. There we go. Then we're going to count the horizontal length. So my horizontal length, I'm going to go 1, 2, 3, 4. So I've got a horizontal length of 4. Then I'm going to write this relationship, my 6 compared to this 4, as the vertical height, so our up and down height, over our horizontal height. So it's going to be a fraction. We're going to have the vertical height, which we said was 6, over the horizontal height, which we said is 4. So that was our 6th step. Write the fraction, vertical height over horizontal length. Then we're going to simplify this fraction and make sure it has the sign from step 1. So 6 over 4 can be simplified to be 3 over 2. but I know this has to be a negative slope because in step 1, we determined that this slope is negative. So let's do one more example when we look at a graph that's not counting by ones. So the graph I'm going to use is a little bit blurry, so stay with me, but I'll tell you what it is that we are looking at. So let's look at this graph. This is a position versus time graph. We count by ones down here, and we're counting by twos up here. So my steps are the same. I'm going to determine if the line is positive or negative. This line is going upward, so I know it is positive. Then I need to choose 2 points that fall exactly on the grid line. So I'm going to follow this line, and I want 2 coordinates that I can tell exactly where they are located. Then I'm going to follow the grid to make a right triangle. So I'm going to draw my vertical line and my horizontal line to connect these 2 points with a right triangle. Doesn't matter if we go above the line or below the line, we'll get the same answer in the end. My 4th step is to count my vertical height. This vertical height is 3 grid lines. It's 3 boxes, but I have to see that we're counting by twos on this axis. So this is really 2, 4, 6. Then I need to count my horizontal length. The x-axis, my horizontal, is counting by ones. So this one is just normal. I'm counting by ones. I have 2 of the boxes, so I've got 2. Then I'm going to write this as my vertical over my horizontal. So we've got 6 over 2. 6 over 2 can be simplified to 3 over 1 or just 3. And we've got a positive slope, so we don't have to add a sign here. We know that the rate of change or the slope of this graph is 3. Next, we can be given an equation. Equations are super easy to figure out what the slope is because they just give me that number. So when your equation is in slope-intercept form, it's providing exactly what it's telling you. It gives you the slope and it gives you the y-intercept. That's why we call it slope-intercept form. So when we're identifying the slope from an equation, all you're doing is looking for the x and asking yourself, what is its coefficient? So I'm identifying the x, and the number and the sign attached to the x is my slope. So in this case, my slope is negative 3 over 2. And that's it. We just want to be mindful when we are given an equation where it looks like x doesn't have a coefficient. So in this case, see how my x doesn't have a coefficient? It really does have a coefficient. Its coefficient is just 1. Because remember, when we don't have anything in front of our variable, there's an invisible coefficient of 1. So our slope for this equation is 1. If there's a negative sign and no number, then we just know that the slope is negative 1. Oops, I spelled slope wrong. So that's pretty straightforward to do. Let's just do a couple more for practice. The slope of this equation, you're just looking for the variable and seeing what's attached, is 3/5. If there's a negative sign, you want to make sure you include that. So of this next equation, it's negative 3/5. So pretty straightforward. And then lastly, we have everyone's favorite, from context. So this is when I am given a word problem and asked for the rate of change, or I'm being asked, to create the equation. And in doing so, I have to find the rate of change or the slope. So what I'm going to be looking for in context is you're looking for a variable that changes along with change in another variable. So the most common real life example we will see is your pay. So if you make $7 an hour, that is your rate. That's the rate of change. For every increase in a 1 hour, you make $7 more. So in this little example we have here, it says each hour Marco earns $12. So I know that Marco earns $12 per hour. So if I was asked for the slope in this scenario, it would be 12 over 1, because that's our changing variable. So this is our number, our dependent variable per independent variable. So the number that changes, so my amount of money is what's going to change depending on the number of hours I work. So let's look at a couple of examples for this, because I definitely think this is our trickiest one. So let's start with this first example. Graham is hiking at an altitude of 14,040 feet and is descending, which is a word that means going down, 50 feet each minute. So we're given two numbers in this scenario. We are given this starting altitude, this starting height, and then we're given a decrease in 50 feet per minute. So what we're looking for when we're looking for our slope is we're looking for the thing that is changing. My starting height isn't changing. That's where he starts. What's changing is my height after time passes. So if I'm decreasing because I'm descending, I know that I'm going down 50 feet per minute. So what we would do if we were writing this as a slope is it would just be negative 50 over 1, or just negative 50. This one says Max is hiking at an altitude of 12,500 feet and is ascending, which is our word for going up, 20 feet each minute. So just like before, we're giving these two different numbers, but what I need to look for when I'm looking for the slope in context for my rate of change is I'm looking for something that's changing with something else. So my amount of feet is increasing by 20 feet each minute. So we've got this positive 20 feet per minute, which would just be a slope of 20. We have time for maybe two more. So let's look at this one. Nick weighs 160 pounds and is gaining about 3 pounds per week. So if Nick weighs 160 pounds and he's gaining 3 pounds per week, I can look at this and figure out what is the thing that is changing. The thing that is changing is how much weight I have gained. How much weight has Nick gained given our number of weeks? So 3 pounds per week, and we're gaining, so this is a positive slope. So we're increasing 3 pounds per week. So that is just a slope of 3.